Hello, good morning students. Myself Pawar MS from KJ Somaya College, Kopargaon. So we have to discuss in our today's lecture our next rearrangement, that is a fries rearrangement. So this is our next rearrangement in rearrangement chapter. So we have to discuss the discussion about the fries rearrangement. So this is the fries rearrangement. In fries rearrangement, we have to discuss here the outline description of price rearrangement. So phenol reacts with acetic acid, so formation of the phenyl acylated product. In next step, we have to use any Lewis acid in presence of nitrobenzene, which gives rise to the formation of final product, that is a ortho product or para product. So it depends on the nature of the substance or which condition we have to use. So see here, this phenol reacts with acetic acid, so formation of the orthoacylated orthoacylated phenol. So this intermediate reacts with the in presence of AlCl3 with nitrobenzene, formation of the final product, that is a C-acylated product will be obtained, that is a acylated phenol. So this product will be ortho or para. It depends on the condition of your mechanism. So this product is ortho or para. So this is the outline of the price rearrangement. See here, we have to discuss here statement of price rearrangement. So this outline we have to give the information of price rearrangement. Simply phenol, the phenol derivative, phenol reacts with acetic acid. So we have to give ortho, we have to give ortho acylated phenol product, phenol intermediate. So it's again reacts with reacts with AlCl3 in presence of nitrobenzene, formation of C-acylated phenol, that is a carbon acylated phenol, which will be either ortho or para. So this is statement of price rearrangement. So we have to discuss here the general reaction. So this is your phenol reacts with acetic acid OH C double bond O CS3. In first step, dehydration takes place, means this water molecule can be depart. So formation of the, we have to give ester of phenol, that is a O C double bond O CSC. This is the ester of the phenol, means your phenyl acetate. When phenol reacts with acetic acid, dehydration takes place and formation of your phenyl acetate. This is also the ester. Then we have to, it's called as a phenyl acetate. So phenyl acetate reacts with again AlCl3 in presence of nitrobenzene. Nitrobenzene. So we have to give this AlCl3 is a Lewis acid. Formation of the OH O C double bond O CS3 and OH O C double bond O CS3. So this is your ortho acid acetylphenol, and this is para acetylphenol. So we have to discuss here general reaction. Phenol reacts with acetic acid, formation of the phenyl acetate derivative. Then phenyl acetate derivative reacts with again AlCl3 in presence of nitrobenzene. We have to give two products, that is a orthoacetylphenol and para-acetylphenol. The formation of the product will be obtained in two product, that is a ortho or para product. So this ortho and para product depends on your condition of the temperature. Okay, so AlCl3 reacts with this phenyl acetate. So here heating in presence of AlCl3, formation of ortho and para. So in which condition ortho product will be obtained and in which condition para product will be obtained. So we have to discuss here. See here. So it depends on your temperature. So temperature will be low. Temperature condition will be low. The para product will be major product or a stable product. So here formation of the ortho and para. So in this both product, which is more stable, the ortho and para product will be stable, which it depends on the temperature condition of the reaction. So temperature condition will be low. Where your temperature is low, formation of the para product will be major product, and temperature condition high temperature, ortho product will be major product. So if you understand what is major and what is minor product will be obtained when low condition, temperature condition will be low, then formation of the para product, and temperature condition will be high or temperature is high, so ortho product will be obtained. When your temperature condition will be normal temperature condition, normal temperature condition, that is a, for example, 25 degrees Celsius, 30 degrees Celsius, this is your normal temperature condition. So formation of the product will be ortho plus para. So if you understand in which condition we have to give the para product or ortho product. So these two things are remember very well. In temperature condition low, that is a para product will be obtained, and your temperature condition will be high, so formation of the ortho product will be formed. And normal temperature condition, that is a para plus ortho product, both product will be obtained. So in next step we have to discuss the detailed mechanism of price rearrangement. But after remaining, so para product will be formed, your product will be depends on temperature condition, that is a low temperature condition. Here formation of the hydrogen bonding, but which type of hydrogen bonding? Here intermolecular intermolecular hydrogen bonding will be obtained. So formation of the para product, and here also the hydrogen bonding is possible, but which intramolecular hydrogen bonding. Here intramolecular hydrogen bonding will be formed, then your ortho product will be stable, and here intermolecular hydrogen bonding will be formed, and para product will be stable product or a major product obtained in the reaction mechanism. Understand? So the mechanism we have to discuss here in detail. Temperature condition, remember one thing again, your product depends on your temperature condition. In both product, hydrogen bonding is possible, only difference in intermolecular and intramolecular hydrogen bonding. So first of all we have to write here intermolecular mechanism. First of all we have to take the phenol and reacts with the acetic acid, formation of the phenyl acylated product. So we have to take here directly O C double bond O CS3, that is a phenyl acetate. So this is the phenyl acetate derivative, reacts with the Lewis acid AlCl3 in presence of nitrobenzene. So this is Lewis acid because of in aluminium, we know the in aluminium vacant pz orbital will be empty, so that's why it acts as a Lewis acid, or in vacant pz orbital it acts as a Lewis acid. So here presence of the non-bonding electron pair, so lone pair of oxygen attack on this AlCl3, so formation of in next step O C double bond O CS3, as it is here AlCl3. So this oxygen carries positive charge, and this aluminum carries negative charge. Why? Because of the valency of aluminum is 3, because of in vacant pz orbital, that is the 3 electrons are present, so formation of the negative charge over the oxygen atom. Why? Because of here increase the valency of aluminum, and this oxygen carries again positive charge. So in next step, here oxygen presence of the two lone pair, one lone pair used for the bond formation, and one lone pair will be remaining as it is. So in next step, this bond can be break and stabilize the positive charge over the oxygen atom. So minus COCS3 depart, but this carbon carries positive charge because of this carbonyl carbon are also also carries the positive charge. It not always in negative charge formation. Okay, minus COCS3 in the form of C plus CO3 COCS3 plus in the form of remaining this rearrangement. So here formation of the again O AlCl3 negative charge, and here minus COCH3 will be depart. In next step, here again presence of the two lone pair of oxygen. So in this step, next step, this lone pair of oxygen takes place here. At that time, here formation of the carbon oxygen double bond, and this bond shifts on this benzene ring. So formation of the negative charge over this benzene ring. In next step, formation of the carbon oxygen again double bond AlCl3. This aluminum carries negative charge. Again this oxygen carries positive charge. So sorry. So here formation of the negative charge because of here lone pair takes place and this bond shifts on this benzene ring. In next step, we have depart the this acetate group COCH3. So minus COCH3 we have to again takes place here. Here negative charge, here positive. This is the nucleophile, this is the electrophile. So this electrophile attack on this negative center on this benzene ring. So formation of again, see here C double bond O CH3, and here oxygen carries positive as it is, and AlCl3 carries negative charge. So here presence of the one hydrogen of the benzene ring. So aromatization is takes place. So this hydrogen used for here double bond formation. At that time, this bond shifts on this oxygen atom. So stabilizing positive charge over the oxygen atom, and one Cl can be depart here in the form of SCl. So see here formation of the again O AlCl2, and here CO CH. See here, simply here minus SCl can be depart. This hydrogen used for the double bond formation or aromatization takes place. So formation of the double bond, and here this bond shifts on this oxygen atom, stabilize the positive charge over the oxygen atom, and at that time one Cl can be depart, means one SCl can be depart here. So formation of the AlCl2O COCH3. This product will be obtained. In next step, simply in in acidic condition, that is a EHCl means EH plus condition. In acidic condition, this lone pair of oxygen abstract the acidic proton. At that time, this AlCl3 can be depart in the form of Cl minus Cl, reacts with this AlCl2. So formation of the, we have to get your final product, that is a OH C double bond O CH3. This is the orthophenyl acetate product will be obtained, or this is the ortho product will be obtained. This is the mechanism of Fries rearrangement. See here OH C double O CH3. But in intermolecular hydrogen bonding, we have to get the para product. Okay, and in intramolecular hydrogen bonding, we have to get the ortho product. So we have to take here the mechanism of intermolecular mechanism. So this is the mechanism of Fries rearrangement. This mechanism in ortho and para product will be same. Only change its only minor change on this reaction mechanism. So in intermolecular hydrogen bond, we have to get para product. Okay, so this is the overall reaction mechanism of Fries rearrangement, and we have to take here C. We have to take this intermediate, that is a O AlCl3 negative charge. This intermediate we have to take here again. So in last step we have to find out the para product. Okay, so here presence of the lone pair of oxygen. So lone pair of oxygen takes place here. At that time this bond shifts on this carbon, and at that time this bond again shift on this benzene ring carbon. So formation of the here, see here, carbon oxygen double bond. Here again Al Cl3, positive charge, negative charge. This double bond as it is, this bond shifts on this carbon. At that time this carbon carries negative charge. So we have to take here your minus acetate group. So this acetate group can be attack on this center. So at that time formation of your acetate group on para position, this bond as it is here, C double bond O CS3. Simply here we have to take this intermediate phenol reacts with the LCl3. So formation of that intermediate, this intermediate can be reacts with acetate group COCS3. So formation of that product will be this way. So here presence of the one hydrogen. So this hydrogen shifts here. So formation of the carbon carbon double bond. At that time this bond shifts on this carbon, and this bond shifts on this oxygen atom, and minus Cl can be depot. So formation of the product. So in this way O Al Cl2, and here C double bond O CS3. So simply in acidic condition SCl, formation of OH, and here CO CSC, that is your final product, that is a para product. Okay, so para acetyl phenol, this is your major product in the condition of intermolecular hydrogen bonding. In intermolecular hydrogen bonding temperature condition is low, so formation of the para product, this para product will be obtained. So we have to take the low temperature condition and high temperature condition. In low here we have to need for the low temperature condition. Why? Because of in low condition intermolecular hydrogen bonding will be possible. Suppose we have to take the high temperature condition. So in high temperature condition your substituents are ions of the reaction mechanism collapse each other or far away from the each other. So in low temperature condition, see here your OH C double bond O CS3, and your OH CO CS3. So in high condition temperature condition, these two molecules are far away from each other, or away from each other from many times in high temperature condition, but in low temperature condition this product will be stable on this system, it does not take part from each other. So here low temperature condition hydrogen bonding will be possible, or not high temperature. Why? You understand? Okay, in intermolecular hydrogen bonding, so temperature condition is low temperature. Same mechanism we have to discuss here in intramolecular hydrogen bonding mechanism. See here again, same way intramolecular mechanism. Here temperature condition is high because of hydrogen bonding in intramolecular. So we have to take here this intermediate, that is a O COAlCl3 minus here positive C double bond O CS3. This intermediate we have to take here. So here presence of the lone pair of oxygen. Here this lone pair of oxygen takes place here. At that time this bond shifts here. In previous mechanism we have to take the COCS3 can be depart in the form of minus COCS3 and then reacts it para position. But here in this intramolecular hydrogen bonding, see lone pair of oxygen takes place here. At that time here formation of the carbon oxygen double bond and this bond shifts on this benzene ring. Here formation of the negative charge. This mechanism we have to discuss in detail mechanism of Fries rearrangement. Okay. So in previous step, so here formation of the negative charge, but in this step here formation of the carbon oxygen double bond. At that time this bond shifts on this carbon, so here this bond can be break, this oxygen carbon bond can be break or stabilize the positive charge over the oxygen atom from this side. Okay, see here again lone pair oxygen takes place here. So formation of the carbon oxygen double bond, this bond shifts on this benzene ring, formation of the negative charge. But here we have to know the COCS3 can be depart. So the COCS3 can be depart and at that time again reacts with this negative charge. This is the simultaneous mechanism. This is the concerted mechanism, one step mechanism. See here again OAlCl3 minus positive charge C double bond O CS3. Here presence of the double bond, so lone pair of oxygen takes place here. At that time this bond shifts on this carbon. Here again formation of the negative charge over the benzene ring, so this bond can be break minus COCS3. So the COCS3 reacts with this benzene ring immediately in one step mechanism. See here again, so this bond can be break. At that time this bond directly attached to this again this negative charge. This is a simultaneous or bond breaking and bond formation reaction takes place in one step. So formation of the we have to get here double bond O Al Cl3 minus, this oxygen carries positive charge. Here again addition of this COCS3. This minus COCS3 can be depart, but is directly it again immediately reacts with this center. Okay. So formation of this intermediate. Here again presence of the one hydrogen takes place here. At that time this bond shifts on this oxygen atom and one Cl can be depart again. So minus ESCl can be depart. So formation of the again C double bond O CS3. Here formation of the OAlCl2. In next step in solvation in acidic condition, H plus, this oxygen carries this H plus and AlCl3 minus again depart this reaction center. So formation of your final product, that is a ortho acetyl phenol can be obtained as a major product in high temperature condition. This is your ortho product, ortho acetyl phenol. This is your major product of this reaction mechanism. Okay, this is all about the Fries rearrangement. I think you have the understand this all mechanism in very well. So our remaining part we have to discuss in next lecture. Thank you very much.